Hi and welcome to this week's lesson from TheMathsTutor.ie for Leaving Cert Ordinary Level Maths. This week we're going to start looking at geometry, and in particular we're going to start looking at triangles and parallelograms and a little bit about angles as well. As always, there's loads of resources available for all the full members on TheMathsTutor.ie, and we make some of those videos available to everyone tuning into these lessons each week. So the first video this week is on angle chasing, so that's about working out the different sizes of angles and some of the rules that go with them. And the second video is on congruent triangles. So congruent triangles are triangles that are exactly the same, and this video explains how we can prove that triangles are exactly the same. So make sure to check out those videos after this lesson. Okay, so today we're going to start with our geometry by talking about angles. So the first thing that I have here are two parallel lines, and I know that these lines are parallel because we have these little arrows on them marked here that tell me we have parallel lines. And then we have another line going across them, and we describe this as a transversal. And when we get this, we're going to end up with lots of different types of angles that we're going to be looking to spot in different types of questions. So just to do a quick recap of some of these, we have something called vertically opposite angles. So vertically opposite angles are where we get two lines that cross and make a shape like an X. And when we get a shape like this, the angles that are opposite to each other are equal in size. So I can see that on this diagram where I have my two parallel lines and my transversal, I can see that this angle here will match this angle here, and this angle here will match this angle here. So there's vertically opposite angles there because I have two lines crossing. Now I also have two lines crossing down further down, and I see that these angles here will match and these angles here will match. And when we're asked about angles, we always have to give a reason for it as well. So I'd be explaining in this case here that we have vertically opposite angles. The second type of angle that we're going to come across are alternate angles. And alternate angles, we're looking for two parallel lines and a line that's going across them. So we get a letter like a letter Z. Now the Z might be backwards, it might be upside down. You just have to have a look for it and see, can you spot a Z? So I can see with these parallel lines, I have a Z forming here, which means that this angle here is equal to this angle here because they're alternate. So those angles there that are marked with the same green mark are going to be the same size. Now we've already said, because they were marked with red, that they were vertically opposite to other angles as well. So now we can see that we have lots of angles that are going to equal each other in here. So there's a backward Z. I have another Z here that's a forward Z. So we'll just switch to a different color. And I can see here's another Z, and that tells me that this angle here is equal to this angle here, and they're also alternate angles. And again, I had marked those with a red dot, so we could see that they were vertically opposite to this angle and vertically opposite to this angle. So now we have lots of angles that are going to be equal to each other. The third type that we have are called corresponding angles. And corresponding angles, we're going to look for an F. So again, we'd have parallel lines. So these lines are parallel, these lines are parallel, and this time we'd have a line coming across them. So when I go back over here, this is starting to look a little bit messy, but when I go back over here, if we switch to the highlighter, I can see that I have an F here. And it's the angles that are tucked into it. So this angle here is equal to this angle here. They're corresponding angles. And when I have those corresponding angles, this is corresponding angles with two parallel lines. We're also going to see corresponding angles in triangles. So corresponding angles in triangles will be angles that are the same size, just in a different position as well. And the last type of angles that we're going to look at where we have these parallel lines are going to be called interior angles. And interior angles are when I have two parallel lines and they're joined here. It's going to be the angles that are inside here. Now this time they're not equal. So in my vertically opposite angle, my angles were equal. In my alternate angles, my angles were equal. And in my corresponding angles, my angles were equal. But in my interior angle, they're going to be different sizes, but the sum of the angles is going to be 180 degrees. So we'll come across that, our interior angle as well. And I can see my interior angle over here if I look at this part here, we see that these two angles here and here are going to sum up to give me 180 degrees. So you see that that ends up being very messy when I'm trying to find these angles, but hopefully I won't be looking for them all in one go. We're just trying to pick out, do we have vertically opposite angles? Do we have alternate angles? Do we have corresponding angles? Or do we have interior angles that are going to sum up to give us 180 degrees? So that's when I've got these lines, and these lines are going to appear in different shapes, and one of the next shapes that we're going to see are our triangles. So when we're dealing with our triangles, we have a few different types of triangles. One of the most important ones are right-angled triangles. So right-angled triangles get used an awful lot in trigonometry, and it's where we're going to have two sides of our triangle meeting at a right angle, and the third side is going to be called our hypotenuse. So when we're dealing with our right-angled triangle, we always have to have that 90-degree angle in there. The triangle that I have drawn here, I can see that this is an isosceles triangle. And why I know it's an isosceles triangle is that these little lines here tell me that these two sides are the same length. So when I have two sides the same length, I'm going to have an isosceles triangle. And when I have two sides the same length, I also get two angles of equal measure. So in the isosceles triangle that I have drawn, the angles that are of equal measure are down here at the base. You just have to be careful to see where they are. So when we have our two equal sides, they'll always be at the bottom of those two sides. So not the one where the two equal sides meet, the other two angles will be equal in measure. The third type of triangle that we're going to see is an equilateral triangle. And in an equilateral triangle, all three sides are the same. And all the angles are the same. So the three angles will all be the same size, and they'll all be 60 degrees. And why they're going to be 60 degrees is that in every triangle, the three angles add up to 180 degrees. So if I have a triangle and I don't have a right angle in it, and I don't have two sides the same, and I don't have three sides the same, we call that a scalene triangle. So your scalene triangles are all the other triangles that are not equilateral, not isosceles, or not right angled, but in every single triangle, the three angles are going to sum up to give us 180 degrees. The last shape we want to look at this week then are our parallelograms. So when we have a parallelogram, the first thing is that we're going to see it has four sides, which makes it a quadrilateral. So all quadrilaterals have four sides. This is just a particular special type of quadrilateral. And with our parallelogram, opposite sides are equal in length. So remember, we had that little symbol there in our triangle, our isosceles triangle, to tell us that they're the same length. So the top and the bottom of this parallelogram are going to be the same length. And the other two sides are also going to be equal in length, but they won't necessarily be equal to the top and the bottom. So here I've marked them with a different symbol to say that they are equal to each other. It's also called a parallelogram. So a parallelogram comes from the word parallel. So opposite sides are parallel to each other. So we had our little arrows to tell us that we had parallel sides. So these two sides are going to be parallel, and the top and the bottom are going to be parallel to each other. And the last thing we need to look at with our parallelograms is that opposite angles are going to be equal to each other. So here, this angle here is going to match this angle down here, and this angle down here will match this angle up here. So opposite angles are going to be equal to each other. I also see that I have this interior angle here. So these two here will sum to 180 degrees. Okay, so they're the things that we need to know about our angles and our triangles and our parallelograms for this week to be able to attempt some of these questions from the papers. So the first question that we're going to look at here is 2020 Paper 2, Question 6. Okay, So this question, in the diagram below, it says the size of the angle CAB is equal to 80 degrees and the size of the angle DCE is equal to 60 degrees. Now, how I know that that's what this is saying is that when it's written like this, the two straight lines here are telling me the size of, and this little symbol that looks like this is the angle. So I know that we're dealing with the size of an angle. And I'm given 3 letters for the angle. So this one here says the size of the angle CAB is equal to 80 degrees. So to find where this angle is, it will always be at the middle letter here. This says start with the letter C, move to the letter A, and then move to the letter B. So I'm going to start at the letter C, I'm going to move to the letter A, and then I'm going to move to the letter B, so I can see that this is this angle up here. Now they've already filled in for me that it's 80 degrees, but they're just telling me that as well up here in the explanation, and I always read the explanation fully to make sure that they have filled in all the details for me, because they may not put everything into a diagram. And the size of the angle that starts at D and goes to C and goes to E. So we're starting at D and we're going to C and we're going to E, and it tells me that that's 60 degrees. So they're the two angles that I know in size, 60 degrees and 80 degrees. And then the other angles are going to be given to us in terms of letters. So the size of the angle that starts with the letter A, moves to B and goes to C is equal to x plus y degrees. So that's marked here, x plus y degrees. And the size of the angle that starts at the letter B, goes to the letter C and then to the letter A is going to be 3x plus y degrees. So it starts at B, goes to C and then to A. So that's this angle here. And it tells me that x and y are elements of n. So this means they're natural numbers. So they're going to be positive whole numbers. So the first part of this question says find the value of x and the value of y. So we need to figure out what information are we given in this question to be able to solve for these. So I'm not told that we have parallel lines. So I'm not looking for alternate angles. I'm not looking for corresponding angles. But I do see that I have 2 lines crossing at this point here. So this tells me to look for vertically opposite angles. So when I have my 2 lines crossing, this angle here is going to match this angle here. So that's the first piece of information that I'm able to spot in this diagram, that 3x plus y is equal to 60 degrees. Now I've made an equation and it has x's and y's in it. So I'm thinking down the lines of simultaneous equations. So when I have 2 unknowns, and here the 2 unknowns are an x and a y, and I'm going to be looking for 2 pieces of information about them, I'm going to try and get simultaneous equations. So that's my first equation, looking at my vertically opposite angles. The second piece of information is that I have some information about all of the angles in this triangle here. So in the triangle ABC, I can see that those 3 angles will add up to give 180 degrees. So that'll be 80 degrees plus x plus y degrees plus 3x plus y degrees is going to equal 180 degrees. And now I have a second equation with the same unknowns x and y, so I can now solve these using simultaneous equations. Now I'm going to tidy up this second equation here before I start. So I'm going to put my x's together and put my y's together and then put my numbers together. So I can see that I have plus x plus 3x, so that gives me 4x. And I have plus y, so I have plus 2y. And I'm going to subtract 80 from both sides. So I'm going to say 180 degrees minus 80 degrees. And that gives me 4x plus 2y is equal to 100 degrees. So now I have 2 equations in x and y. 3x plus y is equal to 60. And 4x plus 2y is equal to 100 degrees. And I'm going to solve these 2 equations to solve for x and y. So remember, when we're doing simultaneous equations, we need to get the numbers in front of one of the unknowns to be the same, but the signs to be different. So I'm going to take the second letter here. So I have a plus y in this equation and a plus 2y in this equation, and I want them to both have a 2 in front of them, but one to have a plus and one to have a minus. So I'm going to take this top equation here and multiply it by minus 2. And when I multiply that one by minus 2, I get minus minus 6x minus 2y is equal to minus 120 degrees. And I'm going to leave this equation alone, and I get 4x plus 2y is equal to 100 degrees. So at this point here, I can see that I have the number 2 in front of my same unknown, but one of them has a plus and one of them has a minus. So I'm ready to add together these two lines. So I say minus 6x plus 4x, so that gives me minus 2x, minus 2y plus 2y, they cancel out, and minus 120 plus 100 gives me minus 20 degrees. So minus 2x is equal to minus 20 degrees. I'm going to divide both sides by minus 2, and that gives me that x is equal to 10 degrees. So that's my first unknown solved for. X is equal to 10 degrees. And now we have to substitute that back into one of our equations and solve for our other unknown. So our other unknown we're solving for here is y. So I'm going to go back to my original equation here, and I'm going to say 3 times x is 10 degrees plus y is equal to 60 degrees, and that gives me 30 degrees plus y is equal to 60 degrees, and I'm going to subtract 30 from both sides. So I get y is equal to 60 degrees minus 30 degrees, which gives me y is equal to 30 degrees. So there's my answer for x and y, and I just have to fill them in when I come down here to the bottom. So we've said x was 10 degrees and y was 30 degrees. Okay, so that's our first part where we had this simultaneous equation because we were looking for two unknowns and they're both natural numbers, and we just had to realize that how we read our angles and how we're going to deal with that. So we had vertically opposite angles giving us one equation and the three angles in a triangle adding up to 180 degrees to give us our second equation. That's part A. The part B of this question then is quite different. So it says in the diagram below, DE is parallel to FG. Right, so I'm told that DE is parallel to FG. So that's the line that goes from DE, which is this line here, is parallel to the line that goes from F to G, which is going to be this line segment here. I'm also told length. So again, I have these two straight lines here. So that's the length of the line segment from D to H is 5. So they've told me that. The length of the line segment from H to E is 12. So from H to E is 12 centimeters. They've told me that. That's filled in. The length of the line segment from H to G is 30 centimeters. So that's filled in here. And then the distance from D to F is X centimeters. And that's filled in there. And our question is to find the value of x. So this is going to use a different type of geometry that we haven't seen yet. And this is where we're going to see our similar triangles. So when I have similar triangles, they're not the same as congruent triangles. So congruent triangles are where we have two triangles that are exactly the same. So every single thing about them is going to be exactly the same. Similar triangles, which we have here, are sometimes called equiangular triangles. So similar triangles are equiangular. So equiangular means that their angles are going to be the same. So here we don't know anything about the lengths of the sides. They may or may not be the same, but when we're dealing with similar triangles, we're going to know that their angles are the same size. So I have this angle up here is equal to this angle up here. I'm going to have this angle down here is equal to this angle down here. And then this angle in this corner is equal to this angle in this corner. So once we can see that we have similar triangles, that all their angles are the same, then we have this rule that their sides are going to be in proportion. Now, it doesn't mean that their sides are the same length. It just means that if this side here was 4 and this side here was 8, I can see that all the sides are going to double. And that meant if this side here was 3, this side here would be 6 because it would have to double as well. It's in the same proportion. And if this side here was 5, this side here would have to be 10 because all the sides are in the same proportion. And that's how we're going to solve this question part B. Now, we don't have two separate triangles here, but I can see that we have a triangle from H to E to D, and we have another triangle that's from F to H to G. Okay. So I have these two triangles, and I want to see if they are similar triangles. So these two little lines here, we were told that these were parallel, and that's going to be important because when I have parallel lines, now I can start to look for my alternate angles, my corresponding angles, my interior angles. So I can see that we're going to have corresponding angles here, where the angle from H to D to E is the same size as the angle from H to F to G. So these two angles here are going to be the same size because we have our corresponding angles, our letter F there, turned sideways. We're going to have the same with our angle from F to G to H. So this angle here is going to be the same size as the angle from D to E to H, so this angle here. And again, they're corresponding angles inside our parallel lines, so our parallel lines and our line going across them, so they're corresponding angles. Now I've shown that two angles are the same using our corresponding angles. The third angle is also going to be the same because the angle that's here from D to H to E is exactly the same angle from F to H to G. So it's the same size angle. So this angle is also common. So that means that this is going to be the same size. I have two triangles here and all three of their angles are the same, which means that I have equiangular or similar triangles. And that means that the ratio of their sides is going to be in proportion. So in our small purple triangle here from D to H to E, I can see that the two sides I have are 5 and 12. And in the larger one from F to H to G, I don't know the full length of this side, but I can see that this part is X and this part is 5. So I could write this as 5 plus X. And in the bigger triangle here, I have that this side here is 30 centimeters from H to G. We can absolutely deal with this using a 5 plus x, but there is a shorter way to do this. So what I'm going to do here is work out the length of this piece here is going to be from H to G is 30, but from H to E is 12. So the distance from E to G is going to be the 30 centimeters minus the 12 centimeters, and that gives me 18 centimeters. So now my sides are going to be in proportion. So I want to put the x on the top to make my life easier. So what I can see is that the distance from F to D divided by the distance from D to H is going to be the same as the distance from G to E divided by the distance from E to H. So I'm going to say the distance from F to D divided by the distance from D to H is the same as the distance from G to E divided by the distance from E to H. Because the ratio of those sides are in proportion, I'm going to get the same fraction when I do that division. So the distance from F to D was x centimeters divided by the distance from D to H was 5 centimeters is equal to the distance from G to E, we've worked out is 18 centimeters, over the distance from E to H is 12 centimeters. So the sum here is actually quite short to do because now all I'm going to have to do is get x on its own and solve for x. But the actual figuring out how to do it is the part that takes longest to describe. So to see where our angles match and then the sides being in proportion is the part that takes a little bit of time on this question. With this, I'm just going to multiply both sides by 5. So I'm going to say x is equal to 18 over 12 multiplied by 5, and that gives me that x is equal to 7.5 centimeters. And that was what the question asked me to do, find the value of x. So by using our ratio of proportion of sides of similar triangles, and we had to look for our corresponding angles to solve that one, then we're able to work out the length of x, and it's 7.5 centimeters. Okay, the second question we're going to look at in this lesson is 2018, and this is 2018 paper 2 question 6 part B. And here we have a parallelogram. So this says the diagram shows a parallelogram with vertices P, Q, or an S. So vertices are just the corners. So I can see that this parallelogram has the corners P, Q, or and S. and it gives me the size of the angles. So from S to P to Q, so from S to P to Q is 115 degrees. The size of the angle that starts at Q and goes to OR and goes to S, so starts at Q and goes to OR and goes to S, is this alpha, this just a letter A type, and the size of the angle that starts at OR and goes to S and goes to P, so starts at OR and goes to S and goes to P, is going to be this beta, which looks a little bit like a B. So it says write down the value of alpha and the value of beta. Now they're not giving me a whole lot of room here to do a lot of working out. So what we can see is that when we have a parallelogram and we're told that it's a parallelogram, then we know that opposite angles are going to be equal in measure. So I can see that alpha here is going to be 115 degrees. And my reason for that would be opposite angles in a parallelogram are equal. And now I just have to solve for beta. So when I want to solve for beta, what I'm going to spot is that here I have my interior angle. So I can see that beta plus 115 degrees is going to sum to 180 degrees. And that's my interior angles. So to get beta on its own, I'm just going to subtract 115 degrees from both sides. And that gives me that beta is equal to 65 degrees. So that's our first part, solving for the size of our angle at S and our size of our angle at OR. The second part, and I'm using the same parallelogram here, says explain why the triangle from P to Q to OR is congruent to the triangle from OR to S to P. Okay, so first of all, we're going to draw that triangle. So we want to fit in that triangle. So we'll just draw from P to Q to OR. So P to Q to OR means that we now have this line here giving us two triangles. Okay, so the triangle from P to Q to OR is going to be this triangle here. And we want to show that it's congruent to the triangle from OR to S to P. So from OR to S to P is going to be this triangle here. Now, one of the videos that we're making available this week is going to explain congruency in a bit more detail. But for now, congruent means that they are exactly the same. And we have four different ways of proving congruency. And the way that I'm going to do today in this question is using side, side, side. So we prove that the three sides of a triangle are equal. That's going to prove that we have congruent triangles. Because we have a parallelogram here, I know that the length of the line from PQ is equal to the length of the line up here in ORS. So we'll just move that back up a little bit to mark that those sides are equal. And we know that the length of the side from S to P is equal to the length of the side from OR to Q. So that's two things that we know about parallelograms. So we're going to write that down. So we're going to say the length of the side from PQ is equal to the length of the side from ORS or SOR, and the length of the side from QOR is equal to the length of the side SP. And my reasons for both of those are opposite sides of a parallelogram. So opposite sides of a parallelogram are equal. So I've proved that two sides of these two triangles are equal. The third side of both triangles is this distance that we've drawn in here that goes from P to OR. So I'm going to say POR, not OR. So the distance from P to OR is equal to the distance from P to OR because it's common to both triangles. So now I've shown that we have all three sides equal. So we're going to say side, side, side is equal to side, side, side. So the triangle PQR and the triangle ORSP are congruent. So we just write in our little finishing statement there or a conclusion. Now we can prove that using two other methods as well. So as I said, there's 4 methods to prove congruency, and if you check out those videos, the second video in particular there on congruent triangles will explain a couple of other methods of proving congruency. So hopefully you found this lesson to be useful to you on starting our geometry with angles, triangles and parallelograms. Thank you.